Dr. Robert Pleming. Robert gained his PhD in nuclear physics at Oxford, and then worked in IT with IBM and as UK Technical Director for Cisco Systems. Before that, he'd been an air cadet and gained a flying scholarship. He has taken on the role of, is it Technical Director for Vulcan to the Skies? Chief Executive, and has the job of getting 558 back to airworthy condition. And we're all really interested to learn how it's going, how you're doing this incredible job of getting one of these aeroplanes back into airworthy condition. Dr. Robert Pleming.
Well, good evening, ladies and gentlemen. Can you all hear me okay? Excellent. For the next 40 minutes or so, I'll be telling you about the story to return this aircraft to flight. But before I start, let me just ask one question. How many people actually worked on the Avro Vulcan, either during its development, production, or of course in RAF service? Would you care to put your hands up? Right. Give me your names at the end of the lecture. On a serious note, it is due to gentlemen such as yourselves, and ladies if they're here, that we are able to do this. If we were attempting it, say, 10 years hence, I doubt that we'd be able to get very far. Now, you'll all be aware that we're getting very close to, firstly, to starting to test the aircraft, and then the milestone of a first test flight. And what I want to do this evening is tell you fairly rapidly about how we've got here and some of the challenges that we've gone through. This is going to be a bit of a gallop through history. It's more recent history, but our story actually starts at Potsdam in July 1945. I don't need to remind you who these three gentlemen are. But at this meeting, Truman was aware that they had just successfully tested the first atomic bomb in New Mexico. He didn't think that Stalin knew, but Stalin also knew. And Stalin was getting really quite worried about this dramatic new weapon. And his fear was the trigger for the Cold War. Interestingly enough, within about a month of this meeting, poor old Churchill had lost his job and was replaced by, and the name has just disappeared. And Clement Attlee, on the 31st of August this year, within just over a month of this meeting, actually committed in a cabinet paper that he wrote, he committed the United Kingdom to the development of its own atomic bomb. Not many people knew that, but it was only about 7 weeks after the US had detonated their first weapon did we ourselves make that commitment. And of course, this is the advent of the famous V-Force aircraft, Victor, Valiant and Vulcan. They were built to deliver this device, which is the Blue Danube weapon, Britain's first production atomic bomb, an enormous device, 20-odd foot long. You can see the scale from the engineer, and about the same explosive power as the Hiroshima weapon, about 18,000 tons of high explosive. And the three V-Force aircraft were developed specifically to take this weapon all the way to the Soviet bloc and to return to whatever there might be left. Our focus is on the last potentially airworthy V-Force aircraft. This is Avro Vulcan XH558. Of all of the 300 plus Victors, Valiants and Vulcans that were made, this aircraft is the only one that is capable of being returned to flight. And I've given you there a potted history of this aircraft. It was indeed, as Tony has mentioned, the first Vulcan B2 to enter RAF service in 1960. And now at the tender age of 47 years old is being readied to return to flight. This aircraft actually has an intrinsic value because not only was it the last aircraft to leave RAF service, but it's also the oldest complete Vulcan airframe in existence. So with that record, we're delighted to be working on this. I'm not going to bore you with very many of these charts, actually. I just need to tell you about what we've been doing. This whole exercise has lasted some 11 years now. In 1996, a few dedicated individuals got together with the idea of discovering whether theoretically we could return a Vulcan to flight. Because we had the common view that this aircraft, of all the aircraft that has been developed in the UK, this one actually represents all that's good in engineering and in flying. It's a remarkable piece of engineering. It took us some time to convince BAE Systems that there was a mechanism, that there was a way that we could return the aircraft to flight. And in 1999, BAE Systems said, yes, we agree with you. We like the project you've put together. We will support the return to flight of Avro Vulcan XH558. This was key because the regulatory environment in which this aircraft will fly is extremely demanding. The regulations covering the flight of a complex ex-military aircraft such as the Vulcan, it also covers the same similar aircraft such as the Lightning, etc., require the original manufacturer and all the manufacturers of critical systems such as engines to be contractually providing design support. And so our first hurdle was indeed to bring BAE Systems on board. Theoretically, we knew we could do it. Then the question was, practically, could we do it? So the next phase was actually looking at the aircraft's technical state, surveying it, asking a number of important questions. Then there was a matter of money. I'll come on to say a little bit more about that. This is not a cheap project, as no doubt you all will know. This has actually cost millions to get this far. That was all under the first phase, which was the preparatory phase. We are currently in this phase we call the restoration phase, which is getting the aircraft back to airworthiness. We call it a restoration because that's a one-word answer. It's actually an extended major service of the Vulcan. We've taken the RAF's major servicing schedule, extended it in some areas, and that is what the aircraft is coming to the end of. Following that, we will return it to flight operations, and we hope to be flying for about 10 years. The limit on that flying life is inevitably engines. Rolls-Royce have given us a limit that will allow us to fly for about 40 hours a year for about 10 years. And after that, we'll retire the aircraft to a National Aviation Museum. With regret, but my view is it should never have been grounded in the first place. I'm not going to go through this chart. All I want to do is tell you about some of the things we checked out during the period after we got the yes from BAE Systems and before we went for the finance. This is all of the things that we looked at. As you can imagine, the whole point of doing this is we have to do it properly, and I wanted you to get a feel of the sort of things we looked at. It's a lot of work. But the nice thing we had was an aircraft that had been kept in almost operating condition from the time of its last flight. It flew into Bruntingthorpe airfield in Leicester, which is obviously where she is today, on the 23rd of March 1993, and from that time was maintained on a 28-day cycle of basically anti-deterioration servicing, and was kept in running condition. This is actually a fast taxi that the aircraft did on November 1999, just before going into the hangar for the start of restoration. The pilot was perfectly happy with the aircraft at that stage. He would have flown it had he been allowed. There was only one thing wrong, and you could probably all notice it, but the port landing light was out. This picture has some importance for me because I was actually in the cockpit that day. These are the sort of things we went through during the technical survey. Looked at the structure. Obviously, with the materials used on the Vulcan at the time, there were some concerns that with age, with time, with moisture, some deterioration had occurred. Wiring. You are all aware of the issues of old aircraft wiring. We looked very carefully at the state of the wiring, and indeed on the work that we've done, we've replaced virtually all of the critical systems wiring on the aircraft. System tests and engine tests. I'm not going to go through any of the results of these, apart from a couple of things. I mentioned the materials. This is actually one of the front spar bottom booms. It's a mass spar boom aircraft. The engineer within BAE who supports us tells me it's actually the same as the Lancaster wing, but I don't believe him. But this thing here, this little hump there, is a oxidation process called exfoliation, and it's a result of the type of material used in the wing. And we did find some areas like that in the wing of this, at that stage, near on 40-year-old aircraft. One of the questions we asked was, is this a problem? For us, the answer came from BAE to say no. They'd actually taken a look at the wing with modern tools and discovered the wing was far stronger than the original designers had thought, mainly because they were using slide rules rather than modern tools. And we could actually polish this out and protect the service with no concerns at all. Another critical success factor was the engines. Those of you who are involved with flying heritage aircraft know that you can repair, restore airframes really till kingdom come. The problem with heritage aircraft is the engines. I don't know if is anybody involved with heritage aircraft flying in here, but for example, I think it's the Sea Fury that uses the Centaurus engine. Would that be right? There's only one airworthy Centaurus engine in the world, and that's on the Sea Fury right now. When it goes unserviceable, no longer will they be able to fly the Sea Fury. We've actually got 8 zero-time Olympus 202s that were in bags and were purchased from the RAF, along with 800 tons of Vulcan spares at the time that the aircraft was acquired. It is these engines which makes the whole project viable, and I have to say we had a Rolls-Royce engineer down at the airfield only yesterday, and he's absolutely astounded with the state of the aircraft, of the engines. Rolls-Royce's view is put them in and switch them on. Just to recap, by March of 2000, we checked out all the things that we needed to check out to determine whether or not at a reasonable cost, i.e. there weren't any major problems, we could return the aircraft to flight. And some of the things we wanted to see were indeed there. I mentioned the spare sets that has in fact been absolutely vital for us. Vulcan documentation, we've got it all, and uniquely for an aircraft of this vintage, there's a complete design record. In microfilm, 140,000 microfilm records down at Avro Woodford, or should I say BAE Systems Woodford. We've got training available, and the last thing to find was the third-party support. Just a quick word about the start of the restoration program. This followed the normal course of a major service, which is basically an inspection, followed by rectification of the problems we found in that inspection, and we found some 2,000 or so individual problems that needed rectification. Overhaul. which is where you take all of the system components off and overhaul them either locally or, indeed in our case, the majority went off back to their original manufacturers. Recovery, which is the state we're in at the moment of building the aircraft back in and then into test. The problem we had in 2000 was finding the money. That was our estimate at that stage on the basis of quotations we'd been given on how much it would cost. And this is a large sum of money for a project to produce a non-humanitarian objective. So we really struggled about how we would do this. So we did all the normal things of public donations and asking for sponsorship. But our salvation was, as you all know, a major grant from the Heritage Lottery Fund. We managed to hit the right time with the Lottery Fund. They were at the time investing heavily in heritage, and the heritage spotlight shines about 50 years ago. So if you remember back into the last decade, there was a lot of work going on with World War II veterans, with recording oral histories and the like. This decade, there's a real focus on the 1950s, which is the decade of the Vulcan. A couple of things to mention about that. You all heard, I hope you've all heard about the new National Cold War exhibition at the RAF Museum at Cosford, which I hear there's a trip on June the 7th. Advertising for you. If you have not yet seen it, it is really worth a visit. It's quite spectacular. And they've got the 3 V-Force aircraft in the museum exhibition building there. It's well worth a visit. That's actually a mock-up of what the building was like. But the Heritage Lottery Fund actually took the decision to give the National Cold War exhibition £4.5 million at the same board meeting that they decided to give us £2.7 million. It's sort of their version of joined-up thinking. But it's been the making of this project. Let me just point out one other thing. That's in the top right-hand corner is a book. It's called Cold War Building for Nuclear Confrontation, 1946 to 1989. And it's an English heritage book. As you know, English heritage looks after our built infrastructure. It looks after houses and the like. Well, this is all about all those things you never heard about. It's about the radar bases. It's about the regional centers of government. It's about the V-bomber bases. It's about underground bunkers, atomic bomb stores. It's absolutely fascinating. And they've got hundreds of pictures. I really, really would like to advertise that book for anybody who's interested in the 1950s heritage. This is part of what we now have available to us, because we've got a major objective. As a result of the Heritage Lottery Fund grant, they didn't give us the money just to restore an old aircraft. What we promised to do is actually help do a couple of extra things. Tell the story of the Cold War. Tell the British public through the medium of flying the aircraft and providing some educational deliverables surrounding it. Tell them about the time of the 1950s. That was the first thing. And the other thing, which I think is just as exciting, is actually to inspire the young in engineering and design. The Vulcan represented a huge step in engineering design, as we've heard from Tony, from aircraft that were previously built in the UK. It was a stunning leap. And what is more, it is absolutely awesome when it flies. I'm sure you all remember this. There is now a whole generation of youngsters who have never seen this aircraft fly, and we're convinced that it will be an inspirational sight for them. It may take some of them along the path of engineering and design as careers. But this is one of the tools that we've got available to us. It's actually the exhibition that was held at the National Archive 3 years ago on the secret state, all about the British government in the Cold War. And it tells the story in a number of ways, a large number of exhibits, and we've actually now got that available for us to use. And the reason why I knew the Clement Attlee cabinet paper existed is because we've got a copy of it. Another relatively boring chart. But I just wanted to point out a couple of things. This is us down here. We're Vulcan to the Sky Trust. It's a registered charity, owns the aircraft and all the assets. And it's the place where the engineering team, the operations team, and also the people involved with fundraising sit. But our extended organisation is actually quite big. The key players in that are Marshall Aerospace, who are our engineering and airworthiness authority, and they actually provide the quality structure in which all of the engineering work is done. Anybody from Marshall's here? Oh, Graham, I didn't see you there. Alongside them, as the original constructor of the aircraft, are BAE Systems. We have to have them involved because, as I said earlier, the regulatory environment demands that they provide a no technical objection type of support. But also, all of these other companies are in a similar position. So Rolls-Royce have signed up to providing the similar support for the engines, and so on. You will recognize all of those names, I'm sure. The one that we struggled with a bit, is there anybody from Messier Doughty here? That's a great relief. The reason is, you've no idea, Messier Doughty actually are responsible for the landing gear. You've no idea how difficult it is getting a French company to support a British heritage project. But we got them on board, mainly because they were the last ones and we could really sort of tease them about it. But this is actually a very important set of companies, and I would say the support has been brilliant. Throughout the last 15 months or so, a whole set of hundreds of components and systems have gone through the process of overhaul or even remanufacture, and the sort of support we've been getting from these companies has been amazing. In addition, there are some 100 other companies who are helping us with smaller parts, but it is uniquely a great British aerospace effort, this whole project. We're just going to go on a tour of the hangar and workshops. I've gone through most of the boring bit now, so this is going to be a little bit more fun. This is where we are right now. So this is the aircraft almost as she is today, apart from the fact that it's actually rather better built than it is here. But I just want to show you a sort of a wide-angle view of the aircraft in the hangar. We'll move around the aircraft. You can see the nose radome is off. That's where the H2S radar was seated. Because of weight and balance considerations, we're actually putting a massive steel plate to represent the weight of the radar in the same position. But we don't need the radar in that current view. One thing I wanted to mention was the superb support we've had from the CAA. Anybody from the CAA here? Right, I can be very truthful then. The guy on the right-hand side is Doug Webb. He's the surveyor from Stansted Airport, who are our local surveyors. And I have to say that, contrary to one's expectations, they have been extremely helpful. The golden rule is, in all this, you do exactly what you're told to do by the CAA. You don't try and sort of argue with them. You actually just accept what they say and do it. And as a result, it's been an absolutely brilliant relationship. That's backed up by guys from the design side down at Gatwick. And I was delighted that Mike Bell, who's the group director of SRG, actually visited us a few days ago, 23rd of April, and he was most impressed. It really makes you feel you're doing things the right way. This is most of our team. They range from people who worked in the RAF on Vulcans as crew chiefs, through to logisticians, and just airframe fitters, trade fitters. It's a relatively small team, as you see, because we are taking a reasonably long time to do this. They are backed up by some 6 or so technicians who are the basically the signature technicians from Marshall Aerospace. But I wanted to contrast that with this team. This is the team from the RAF who did a similar job of work on the Vulcans at St Athans when they were majored down there. There is some real big difference to this. We're taking about 22 months or so to major our Vulcan. These people turned a Vulcan out in some 45 to 50 days. So a rather different approach. Our team, obviously, coming to do something like this uniquely for the first time, one of the first things we did after we'd gathered the team was to train them, and we actually had proper classroom courses, 2 sets of courses, an initial course and then what we call level 3, which is the in-depth training. That was done in classrooms. We've also had some rather important aids generated. This board here is one of 90 or so Vulcan technical training boards that were used by the RAF to train their service people in how the Vulcan worked. What we've done is we've digitized those. They're on high-definition images available on the PCs that we've got around the hangar, so people can actually go and look at these pieces of information. We've actually also digitized the 3,000-page parts catalogue there is for Vulcan, so we can actually search by part number or by section ref amongst this huge amount of information. This, of course, was not available to the RAF in the old days. We've gone through a very extensive amount of non-destructive testing, 480 different X-rays. This is a X-ray shot being prepared of the leading edge, and no faults found. In addition, we've used some very modern equipment to look at places that have never been seen before. We're actually a guinea pig for Olympus KeyMed, who are a medical intrascoping service. They make medical intrascopes, you know, the sort of thing that you get shoved up you. And this is one that's being used to inspect parts of the wing which has never been seen. This part of the wing would have never been seen after manufacture, and it's all in superb condition. We are extremely confident about the state of the structure. I mentioned the wiring. We've extensively rewired the aircraft. All the critical systems have been rewired. As Tony mentioned, the elevons actually rely on electrical power to drive the motor that drives the hydraulic pump on each powered flying control unit. And this is replacement wiring for that. We've got a number of system components. This is a bit of a saga, this one. This is the air conditioning unit. Note, there's no electrical power being supplied to this. It's a marvelous piece of engineering, but it's driven by engine compressor air on the aircraft. We're using a Palouse, but it produces extremely cold air out of the end. You can see the condensation emerging. Marvelous piece of engineering, and this is a brand new one that was in our stock of 800 tons of spares. We've actually made 47 different system deletions on the aircraft. Tony mentioned the military flight system. That's one of them. This remarkable piece of equipment that Tony showed earlier actually drove 2 instruments called the attitude director and the beam compass. And those were just indicators, because behind that was a unit containing 6 different gyros that all had comparisons between them. It's a huge piece of kit. And it's very expensive to maintain. We were told that if they could do it, Smiths would charge us £25,000 each for each of the 6 gyros. Not a game we wanted to be in. So we've actually replaced it with a modern system. This is a Bendix King comfort system coupled to a Garmin GPS, and just with a normal GA artificial horizon. And that's what's on the aircraft now. Net price, £37,000. So it's a no decision from that point of view. A large number of the other operational systems have been physically deleted. So the navigation and bombing system, which is a radar-based sort of guidance system, chaff flare, the rear warning radar. You can imagine there are all sorts of systems, down to individually the ration heaters. Those have all gone. once we've finished the cockpit, if you walked into the cockpit now as a Vulcan pilot, it would look very different from what you would have remembered. Not quite glass cockpit, but getting near. We're now getting to the end of the recovery stage where that green arrow is, and beginning to think about test. We've actually ordered our first load of fuel. 37,000 litres will arrive next week. And hopefully the week after that we'll actually start fueling up the aircraft. So we're gradually getting there. I'm not going to commit any dates. It would be absolutely the wrong thing. I will commit that we're going to be starting testing very shortly. But as for things like first flight date, we can't do it. I mean, we just don't know what we're going to experience during the functional test. So let me forestall that question before you think of asking it. We have been very lucky in some of the equipment we've got at our fingertips. A lot of the test equipment that's required for functionally testing the aircraft is available. This is one example. That blue stand there is the test stand for the Vulcan's 5th engine. That's the Airborne Auxiliary Power Plant, and the test stand below it has been used to ready the 4 spare AAPPs that we have in our set. That's actually been done under the Goodrich banner. Powered flying control units, those have all been overhauled. This is actually 2 of the units going off to Smith's Aerospace at Wolverhampton for servicing. We've received those back, and those are now hanging off the aeroplane. Much work on the landing gear. Landing gear, this is where, interestingly, we're using some of the more modern design criteria. You may not know it, but the Vulcan did not have any ground-air-ground cycle limits on its undercarriage. It was all done on flying hours. And likewise for the engines. But people nowadays want tighter criteria, so we've actually had to get involved with some really deep strip work on the landing gear. This material is an old aluminium alloy forging, and it's not exactly the sort of thing that you would use nowadays. However, all of the inspections have been done, and it's actually all perfectly airworthy. We've got 14 fuel tanks on the Vulcan. Each of those has got a bag to contain the fuel. These bag tanks have been overhauled, and in fact we've remanufactured 2 down at Fireproof Tanks at Portsmouth. Just to give you the scale, that's a door there, and you can see roughly how big this is. Major milestone we had on the engines. There's a unit which controls the fuel flow called the chassis-mounted fuel system. It basically governs the fuel flow depending on engine speed, atmospheric conditions, and the like. It's actually a completely mechanical unit, and all of these we had to get overhauled because of CAA requirements. They've got rubber diaphragms in them, and what you don't want is a runaway engine, because that's a very dangerous thing to happen. So these units, all 8 engines, have been overhauled by Goodrich. It was a Lucas unit. Lucas were taken over by TRW, who then sold that business on to Goodrich. But Goodrich have actually been brilliant. Is anybody from Goodrich here? That's a shame. Plug was missed. But we have actually had to manage this quite carefully. Getting components back on time has been a real tricky process for us, and we've been using a sort of traffic light type chart. This is a real chart from March, and you can see some of the suppliers, key suppliers there, and where we were with various elements of the overhaul and supply activity. Don't want you to read it all. I just want to give you the view that will tell you this is actually quite a complex project. But we've been quite novel in our approaches to this. One of the things we've been doing is using the web. This is a marvelous tool called Issue Manager. And what it allows us to do, and allows all of our supporting companies to do, is actually find out exactly what the state of any particular problem is using the web. So they've all got their user IDs, they log onto the web, they turn up our issue manager, and they can see where things are. It's been an incredibly valuable tool. And at this stage in March, if I can get there, we actually had 49 different problems. So the impression I want you to get from this is it's not all been plain sailing either. It may seem sort of quite glib, etc., as I present it, but it's been an awful lot of hard work for quite a big team. We've had 6 people in the logistics team resolving all these problems, and it's been quite an education. Over this time, we've actually seen inevitably with aerospace projects a price escalation. I mean, despite all efforts, you put every single sort of, are you sure that's what it's going to cost type of questions in at the start, we've actually come out with a rather significant price increase, which we're wearing. I want to remind you, back in July, August of last year, we went through a really difficult phase, but we went out to the public through a pretty intense media campaign and actually asked for the money to take us back on track. We asked for 1.2 million and we got a shade more. It's quite extraordinary. So in 21 days, in August of last year, we raised this money to allow us to keep on going. I have to admit that Sir Jack Hayward, who is a really big supporter of everything British, came forward with a donation of £500,000, which was just fantastic, that we got notice of about 4 or 5 days from the end of August. And we did it, and we were able to carry on. It was the most extraordinary time, I have to say. I don't know whether or not anybody was at this event, but on the 31st of August, we actually rolled the aircraft out of the hangar as a thank you to everybody who'd helped us reach that target. Since then, we've been moving forward. We've done a number of things. This is a mod that we needed to put on the aircraft. This green thing here is actually a strengthening mod for the rear spar bottom boom, and it actually extends the fatigue life of the aircraft by quite a considerable amount. This is an important mod for us. We've done a lot of work on the elevons. This is actually something we had to outsource to a company called Beagle Aerospace. Sorry, Beagle Aircraft that was, not Beagle Aerospace now. The elevons on the Vulcan are really quite big structures. You can see the sort of scale of them on this chart. They're all extremely well balanced. They're actually made of a majority of magnesium alloy. But mag alloy, as no doubt you realize, doesn't react with water very well. So by the time the Beagle had actually come to take the skins off and had a look at the internal structure, we learned that the restoration was going to be quite a lengthy process. We got a quote originally of £100,000 to do this, but unfortunately, Beagle came back in March, just literally a couple of months ago, and told me the bottom line, 283,000. So I'm just sitting here with a big liability at the moment. But the elevons are back on the aircraft, and it does look absolutely superb. This is an aircraft now which is almost, this photograph was taken about 3 or 4 weeks ago. You'll see the elevons were fitted onto the aircraft, and we've been gradually returning the aircraft to its full configuration. We've suffered one more problem, which has actually emerged rather late in the day due to a late finding on our inspection, and that's in the roofs of the landing gear bays, where there was a lot of corrosion discovered on the ribs and stringers. We actually have to lift the planking and replace a number of the stringers. It's taken a long time to do this work. We had 18 contractors working on a 24-hour shift to get this all done in time, but it's been quite an extensive exercise, expensive too. But it has, again, raised our price. We're pretty close to the final figure now, I want to say, because we are so close to the end. So all of the external work in third-party companies has now been completed, and we know the bottom line on that one. But it does mean that we're still looking for money. And outside, you will find Let me just tell you about these now so that I don't forget. This is our marvellous perpetual lottery, which, in return for which you have the chance of winning £558 every month. You need to put in a standing order, which is equivalent to about £1 a week. But it does help us with our forward funding to keep the aircraft flying. I've also given you the opportunity to pick up one of our Supporters Club leaflets, and if you're that way inclined, there's literally tons of Vulcan merchandise that you can buy. So those should be outside for the end of the meeting. Where we are today, I took a quick checkpoint. We've actually got 2 engines installed right now, with numbers 2 and 3 installed. Numbers 1 and 4 are going in next week. Landing gears going on next week. So we're really accelerating through the work. This is rather like, painting a room. There's tons of preparatory work, and then suddenly you slap on the paint and it's finished. That's exactly what we've experienced here. There's been absolutely tons of preparatory work, but now the recovery of the aircraft is proceeding really quite fast. The vast majority of the fuel tanks are ready. Oxygen systems complete. Hydraulics are nearly complete. Pneumatics are complete. Fire detection suppression's complete. Avionics fit isn't complete because we're having to put a couple of extra aerials on it. Where we are right now, I will disown any report of these dates. So, are there any journalists in the audience? We're going to be starting system test very, very soon now. Air test, because of a problem we've got with the PFCU motors, I don't think the mid-June date is achievable. But when we get to fly, it'll be under Marshall Aerospace's direction. We will be flying as part of Marshall Aerospace. And the sort of what we'll be doing then is a very short first flight just to check out the systems, the basics. Then the second flight will take us up to RAF Waddington, where we're absolutely delighted. They've said to come and do your shakedown flying at Waddington. That's important. We don't actually have a compass base at Bruntingthorpe, so we're going to go up there and do important things like swing the compass, etc. And then we've got this air-ground workup. All of this is done under B conditions, so we won't be doing any display flying. We might appear, but it won't be a display. And after that, we do the application for a permit to fly. What are you laughing at? If you want to find out the very latest, do visit our website. There was an engineering update put on only this morning, so if you want to go there, it's a good way of keeping track of what's happening. We will publish news on the project. Before you ask, the first test flight will be media only. We're not inviting the public to the first test flight. Our plan for flying the aircraft will be roughly 12 or so display days a year, and obviously we can do multiple events on a day during the display season, May to September. After that, during the out of season, we'd like to actually use the aircraft productively. So on the currency flights that we have to do, we may well fly to an RAF station, leave the aircraft there for a few days alongside the educational vehicle that we're planning to have, so that we can get some exposure to the aircraft out of the air show season. Just to tell you our gross costs, before anybody asks, for the 40-hour flying season, including all of the public benefit delivery, that's the education, etc., is about 1.5 million per annum. Lastly, inevitably, the question of environmentals comes up. We are, as you all know, an extremely noisy aircraft, and the airfield at Bruntingthorpe is an unlicensed, non-active airfield. It's actually in good condition because it's used for car trials, so the runway's in good condition. But we have no option to take off from there. I just want to show you this chart. In the middle, horizontally, is the runway at Bruntingthorpe, and the red splodges, which you can't read, are actually the villages that have sprung up around the airfield. We, with some trepidation in the middle of March, invited all of the local community representatives in to Bruntingthorpe for a briefing, thinking we're really going to be hit on this one. but I'm delighted to say that the local community is completely on board. They're very proud of what we're doing, and it was really very heartening. So, assuming the weather is in the traditional direction, we'll be taking off towards Lutterworth, which is that big blob there, which is about 2 nautical miles away from the end of the runway, and then turning either left or right to complete a circuit. Our major problem is that blue thing, which you will recognize as the M1. We've actually engaged the police, fire service, ambulance service, etc., because what we don't want is to sort of create a disaster on the M1. But we just, as you would imagine, we have been thinking about all this. Really, just to finish off then, I think I've gone a couple of minutes earlier. It is a unique project. Nobody has ever attempted to do this before, and it is, I think, a remarkably exciting one for everybody. We do have a very substantial amount of public support, as we proved back in August of last year. It is a lot bigger than just restoration and operation of the aircraft. We've got an enormous story to tell, not only of heritage value, but also the engineering side of it and the excitement side of it. I'm really going to be looking at the reaction of the people who've never seen a Vulcan before, because I expect it will be somewhat of a surprise. With that, obviously I'm available to answer any questions. There's so much I haven't told you, but I think I'd better stop there.
Thank you very much.
Thank you. Thank you.
Thank you, Robert, for telling us about this unique and...
Good evening. Thank you for a wonderful lecture. Safety with the fuel tanks. Are you using the system of fuel out, nitrogen in?
No, there's air over the fuel. The fuel tanks are pressurized, but it's air. It's what's important to realize is how ex-military aircraft are certified as safe for flight. And the way it's done is by reference to the in-service safety record and the configuration, the build standard that was used there. So what we're doing is actually taking the aircraft back to a certified build standard for which the safety record is known. That's the way that the CAA certifies it fit for flight. In the particular cases of the fuel tanks, there will be pressurized air above the fuel.
Once you've got the aircraft flying again, will you take your sights to Concorde? That's one question. The other question is, how much do you will you expect to earn per year by showing the aircraft at our shows?
Okay, did everybody hear that? First question was on Concorde. Some time ago, I was actually asked by the Save the Concorde group what my view was. And to be honest, I think that they've stumbled at the first post. It was very obvious when we started with the Vulcan project, the first thing you needed to do was verify whether or not the original constructor was willing to support the flight of the aircraft. And I have to tell you that, unless you don't know, that it was Aerospatiale, I think, I'm not sure of the organisation here, it may be part of Airbus Industry or maybe directly part of EADS. But EADS said absolutely categorically no, we are not going to provide design support for a Concorde flying after its commercial life had finished. And I think that's the end of it. From my view, if you haven't got them on board, you're dead in the water. It's a great shame, but I think it's probably the right decision. The other question, which was...
Income.
Oh, yes. Right. There are several revenue streams associated with flying the aircraft. That figure of 1.5 million per annum is actually found through about a dozen different revenue streams, only one of which is the appearance fee. The airshow industry in the UK is actually vibrant. There are about 6.5 million people who visit air shows every year. It's the second biggest outside spectator activity after football. The various air shows have different characteristics, but they all do pay an appearance fee to the items that appear. We're positioning ourselves in terms of cost at the same level as the Red Arrows, who are the most expensive item in the UK. They actually charge, well, they did last year, about £7,000 per display. So if they appear sort of once on a Saturday, once on a Sunday, that's £14,000. The demand for the Vulcan is very high. I know that if I charged £30,000 for a display, people would, they'd flinch, but they'd probably pay it. But the downside of that is it would wreck the airshow display market, because it would price everybody else out. I mean, they'd afford one item, as it were, and everybody else they couldn't afford to pay it. So we made a policy decision to position ourselves alongside the Red Arrows. So my base price is actually £7,000 per display, and we've actually broadcast that at the Air Display Association. So just to position you. But there are, the big revenue stream for us is actually commercial sponsorship. It's rather like Formula One, but different.
Tony Houghton, ex-Vulcan navigator.
Oh, hi.
You haven't mentioned much about the aircrew. I wondered what the vintage was and what the training involves.
The vintage, or veteran. The aircrew that we have assembled to fly the aircraft are ex-Vulcan aircrew. The first team that will fly the aircraft on the current plan is my chief pilot, squadron leader David Thomas, who was the last pilot to fly the Vulcan into Bruntingthorpe. He's also got terrific experience as he was the bomber leader pilot, the Avro Lancaster pilot for some time on the BBMF. Absolutely brilliant guy for the display of the Vulcan. He will be alongside Al McDickin. Al is, you know Al, don't you, Tony? He's actually, I think, still under contract to BAE Systems as a test pilot. He's a very experienced test pilot. He'll probably be in the left-hand seat, David in the right. And then behind them will be squadron leader Barry Macefield. Again, he's a retired squadron leader. He was the AEO, Air Electronics Officer, on the last Vulcan. And it will be that team of three that will fly the aircraft for the first time. We've actually got an aircrew pool. There are two more pilots. One of my co-pilots is Martin Withers. Those of you who read Vulcan 607 would recognize the name. He's itching to get back into the aircraft. We've taken out the bombing gear, by the way. Mike Pollitt, and there are two or three other people who have gone through the Vulcan Operational Conversion Unit as late as the early 80s. My aircrew currently are all over 60, so we are looking for the younger aircrew, and we do have the opportunity for training up pilots with the right qualities and the right experience onto the aircraft.
Could I ask about supply materials? For a number of years now, materials have gone over to American specification, Hidimidian rivets to Dural rivets and things like that. You've already mentioned that you're using Mag Alloy. Is those materials still supplied in this country to the British spec, or are you having to use American spec with potential problems of electrolytic reaction?
Well, it's interesting. The case of the elevons, where we needed Mag Alloy, we did actually have to go to the States to get the right material, because they were so finely balanced. We actually had to go absolutely for the spec we needed for that material. Yes, we have discovered that there are some materials that we have not been able to find, and one of the design changes required is actually a material substitution type change. Primary example is the deletion of asbestos. There are certain areas in the aircraft where asbestos was used, and we've had to replace that. Good example would be the seals that are used on the hot air ducting system. Those were all original asbestos-containing seals. They're now replaced with a modern material which has got, I think, glass in it. There's been a lot of work, but not as much as you might think. A lot of materials, especially the imperial gauge stuff, are still available. Remember the VC-10s are still flying. VC-10s are actually only 6 or 7 years younger than the Vulcan. There's a lot of stuff on the VC-10s that is still in use, and indeed the techniques that are being used to keep the VC-10 flying have been of very great value to us in taking this aircraft through its restoration.
Could I ask, rivets? British rivets are 90 and 120 degrees. American rivets are 100 degrees. We
haven't found any problems getting British rivets.
You mentioned that this is the only V-bomber that could be returned to service. Why is that the case, and were there any other contenders?
Well, let me just go through these one by one. The Valiant fleet, there's only one Valiant left, and that's the one that's actually at RAF Cosford in the museum there. The Victor fleet are all time expired in terms of fatigue life. You'd never fly one of those. I don't know if you've ever grabbed a Victor wing, and you can actually get it to oscillate. It's a very, very bendy wing. Of the Vulcans that are in existence, there are 2 other Vulcans that are capable of taxiing under their own power, and 2 other Vulcans that are actually under cover. They're in museums, which internally in museums. Those are the only ones that you could possibly consider returning to flight. Of the ones under cover, the one at Cosford has spent years and years and years outside, is internally very badly corroded. The one at Hendon actually had to be cut up to get it inside the museum building, so that's a no-no. Of the 2 that are taxiing, one has got 300 series Olympus engines, so that's a no-no from a safety point of view. And the other one, Vulcan XL426 down at Southend, has actually been kept in a running condition, but only by doing all sorts of botched... Sorry, is there anybody from Vulcan Restoration Trust here? But they've done a valiant job of keeping it running, but only through non-certified mods. And the thing about our aircraft is we were very, very careful to make sure that there was complete continuity from a technical history point of view from the day it left the RAF to today. And without that unbroken link, you wouldn't even get a sight in from the CAA. So, by process of deduction, it is the only V-Force aircraft that can fly.
Apart from the removal of the radar system causing substitute ballast, steel plate, I think you said, has the removal of other systems necessitated similar ballast to be installed?
Yes, so the weight and balance is actually critical. We've removed probably the best part of 5 or 6 tons of kit from the aircraft. We know what we've removed, obviously, but we have to return the aircraft to the same minimum weight as it was released to service, and the same C of G situation. And that is actually the subject of quite detailed analysis. We're doing our first weigh the week after next, getting planeways to come in and weigh the aircraft, because we want to see whether or not our forecast weights are actually correct. But basically, we are adding ballast at the right places to return the aircraft to the same weight balance configuration as it was with all of this kit on. And we have to do it. BA Systems have already made it very clear that the aircraft has to be returned to its original flying weight. We're not going to get a go faster, very light one.
Is the plane going to be able to go to its maximum velocity?
No. We're limited. The aerodynamic limitations that are really quite important. We're limited to 250 knots maximum airspeed normally, but if we're with the Reds, it's up to 300. We're limited to 17,500 feet maximum altitude. obviously at that height, Mach number doesn't come into it, but we wouldn't be thinking of that at the moment. And we're actually only going to take it up to, I think, 1.8 G. Actually, Tony. Those are sort of limits that we're working with at the moment.
Please, can I have a flight in it?
Another condition: no passengers. The CA have made it very clear that they will not entertain us taking passengers. That's fair enough. Our tactics on this one are really to gain experience and to get some flying hours under our belt. Then, if people become more confident in our operation, we'll see. But at the moment, I'm not going to even get a flight, which is a shame. But anyway.
We could go on for a long time, but I know people have trains to catch, so I'm afraid I'm going to have to wind up the discussion now. I'm very sorry, because we could have gone on a lot longer. Thank you again for a super lecture.
Thanks very much.
And for handling the discussion.
Please give our thanks to our speakers.